Hello everyone, I'm Santhilata presenting on behalf of our team. Our research work, the context-based search tool for email archives, developed as a part of our project, historicizing the .com bubble and contextualizing email archives. Our team consists of myself, I'm Santhilata from the National Archives UK, Professor Stephanie Decker, the principal investigator, Professor David Kirsch, and Dr. Adam Nix, along with me are co-investigators on this project. Emails are an important means of communication across organizations since late 90s. Hence, emails have become an important and interesting resource for historians to understand events that have happened across the organization. The emails being real communication between actual people, they give a personal touch to the events and activities that have happened in the past. Recognizing the importance of these emails, many tools have developed for the preservation of emails. They are useful for the legal and archival purposes. They provide basic keyword searches and provide search facility by the inbox of custodian or instance of time. However, these presentation tools that are existing are not suitable for accessing the contents of emails for the end users. Here in this project, we are not considering giving access to the privacy, all those issues that are related to the privacy or sensitivity of the emails. We are now mainly focused on how to develop a search tool that gives the that provides certain context to the user query only. We are wholly focused on the technical part of providing access. And preservation tools are not suitable for accessing the contents of the emails for the end users. They lack in contextual search for the end users who want to retrieve information from the contents of the emails across the inboxes of multiple custodians in an organization. They are useful for search terms, known search keywords, or established topic models, but provide no functionality to explore or deep dive into the particular topics that have got some connections to the keywords that are that user wants to know about, retrieve information about. If these topics are associated with some other not very clear or previously known keywords, then it is not possible to just explore, or they do not facilitate the exploration of the interactions of individuals around these specific issues. The challenges and the challenges and context of the email. When we are talking about the context, we need to know what is the context of the email. And being the first in this research area, we have defined the context for the email. Before that, we understand what is the context for any such digital documents. What is the context of a digital document? Emails have network properties. They are known as, they are often represented as the network graphs. They are represented as graphs with nodes made up of people in, to, from, or CC or BCC of email. And emails present conversations between two or more people in parallel with other types of communications that happen in an organization, something like social media, either Slack conversations or Twitter conversations, the tweets that helps. So emails come under short text conversations. When we are processing using computational models, we have to work on them as short text conversations. And email tracks the development of conversation over the time. So when we are defining the context should be the essence of conversation that should capture the essence of the conversation, who were involved in a particular event, and when the event has happened, when this event has happened. So here is the context of an email. The context we have defined as a triple of who, what, and when. These are the entities of this triple. Who represents the element who represents the people between whom the conversation has happened. And the element what represents, here is the what on the left-hand side, represents the event or task discussed in the conversations of emails. And the third element of the triple is when. It is the time instance or when the conversation took place. So the context graph is the graph of context on the right-hand side. The nodes are the context and the edges are the time duration of an event between people. These edge weights are the number of emails exchanged on a particular event. So and the bottom of this bottom part of this email contextual graph, we can see the network properties of emails, all these nodes being the people in the of the between whom the emails were exchanged, and the same through going through the knowledge extraction, we retrieve it as a bipartite graph, people to the events. And the connections are the edges are the time duration, and the edge weights are vary as the number of emails that have exchanged between the people on this particular event. The definition of the context makes this definition of the context makes the computer modeling easier, scalable, and allows queries to be framed around events and get context of the event, which means a query about an event can lead to other related events discussed in the email threads, and also the contemporary events that happened around the same time. We have developed two models to do this. This is the process diagram for model 1. Model 1 is useful for advanced users who knows what to search in a particular email dataset. So when we say the users who know the particular dataset, one may wonder, why do they want a search tool at all? They may need a search tool to search for the relevant or co-occurred events around the same time of the present event in the query has happened. So this particular model 1 makes use of NLP packages for phrase matching. Here we see in this process diagram user query, and we extract phrases from the user query, and we extract phrases from email documents sequentially. And after the text analysis, we get the important phrases, key phrases, and these key phrases are matched using the key phrase matching from the Python packages such as NLP packages such as Spacy and NLTK. And the output is the email set of emails, a bunch of emails between sender and recipient. And then the model 2 is useful for the users who have no idea about the data set. This is completely, they can present a generic query and get the information about about generic events, what has happened, what is all about, what is the information, more information about the data set, and then they may pose more queries so that it helps. Model 2 helps the novice users of this data set to get a feeling of the data set in general, and then they can go to the model 1 and ask specific queries. This model 2 makes use of bet embeddings to focus on the central meaning of the events and in the what part of the context. It then matches with the semantic meaning of the user query. Here we can see the contextual objects, and it trains the model. Next is here is the overall architecture of the tool. Overall, there is a user interface, and this user interface we have provided users can submit a natural query, and also we have facilitated group selection as well as date selection. Group selection is often we see like users may want to search some. Users may pose queries focused only on the top emails from the top management, or the emails from newsletters, or emails from some IT conversations, whatever it may be, according to the that is based on the data set, email data set that we have got, the important groups. And then date selection is using the date selections. Users may focus on the start date and end date during that time. They want to find all those events that have happened in the context of their query. The default date is the start date of the start email in the email dataset to the end date, that is the last email in the dataset. And here is emails are considered, email collections are processed, that is they get email content, subject, body, attachment, or email metadata network, and using the knowledge extraction using NLP methods, we create a database of contextual objects and contextual object graphs. And for the model 1, The query is the query and the knowledge extracted, that is the NLP method, using NLP methods, is provided to model 1, and the inputs for the model 2 are the query as well as the database contextual object graph. And model 1 and model 2, they process using the model 1, model 2, as I have explained in the previous slides. And the outcome is the set of emails, and then the word cloud with the important words that that we can find within the result set. And also there is a word graph or the timeline graph that gives a scatter plot of when these emails have happened, and when these emails were posted, of emails of interest have happened on a timeline. Since the tool is based on the conceptual meaning, we have designed the subjective evaluation of the tool. And we couldn't do the quantitative analysis. And here the y-axis represents the sample queries that have posed, and the bars on the x-axis represent the fraction of relevant emails out of the result set. So the relevance for the model 1 is nothing but number of emails appropriate for the given query. And the relevance for the model 2 is number of emails above relevance threshold, certain threshold about the relevance, above the relevance. So here we choose 3 groups of queries: specific queries, the queries that contain specific keywords, and then there are generic queries, and then there are some queries that have got multiple meanings. And using the specific keyword queries, here we can see election Bush, that is President Bush, the repercussions of elections on this company by President Bush. And QCO, JD are the keywords, are the names of companies. And here the generic queries category: bankruptcy, whistleblower, and reputational risk. We have we have done this evaluation of the tool. Evaluation of the tool on the Enron database. So bankruptcy, whistleblower, and reputational risk, these 3 are 3 important specific keywords, specific items that that are useful for the Enron data set. So here we can see when we have used specific keywords, model 1 has performed better than model 2. And for the queries that are appropriate to the particular data set, such as bankruptcy, whistleblower, and reputational risk, model 2 has performed better than model 1. And an important point to see with the queries with the multiple meanings, they are generic. We cannot, model 1 and model 2, more or less, they perform the same. If you see election Bush and presidential elections, if you compare these 2 queries, presidential elections, model 2 has picked up the same query results as election Bush. And in the conclusion, this research is aimed at providing access to email archives. We have developed a context-based search tool, eConDist. We have defined the context for emails, which is scalable. Sorry, this research is aimed at providing access to email archives. We have developed a context-based search tool, eConDist. We have defined the context for emails, which is scalable. In our project, we have focused on how to provide access to email archive to the users who want to use emails for content discovery. We have developed a prototype eConDist to assist users with context-based search from emails. At present, the tool starts a fresh search every time there is a new query. It means the edge weights on the context graph are reset to 0 to make the search of each query independent of its previous knowledge. In future, we would like to make use of learnings from the past queries to aid the current search by considering probabilistic edge weights. Questions?